All right, let's look at problem number 18. So the question is, which set of coefficients will balance the equation? All right. To balance this equation, as always, the first thing you need to do is divide the equation on the arrow. All right. And then you start counting the elements one by one. So let's start with C. How many C's do I have? 1. H here. How many H's do I have? 4. And then O, I have 2. On the other side, how many C's do I have? 1. How many H's do I have? 2. And how many O's do I have? Now look closely. On the right side, on the product side, you have 2 O's. O here and an O here. All right. You must clearly show that those 2 O's are in 2 separate places. So you got 2 O's from the CO2, 1 O from that H2O, a total of 3. Right. Remember, we do this to show that because when you put in a coefficient, okay, it doesn't multiply both of them at the same time. I'll show you in a second. So, all right. So you look at them and you look at which ones are not equal. They're not balanced. So if you look closely, guys, the ones that are not balanced is H and O. Right. But remember, you always do O's last. And if an element shows up twice on one side, you do that also last. So let's do the H. Right. So look at H. You got 4 on the left, 2 on the right. So which side needs more H? Which one is the low side? It's the right side. See it? Okay. So how do you balance this? Remember, the rule is you look for a number to multiply to the low side to make them equal. So I need to multiply this by a number. Again, how do you get that number? It's going to be the high side, which is 4, divided by the low side. So 4 divided by 2 gives me 2. And that's my number. All right. 2 times 2 gives me a 4. Right. It's now equal. All right. Guys, we're not interested in the 4. What we're after is the 2. That multiplier becomes your new coefficient. So put a 2 here. All right. Check if that 2 multiplies anything else. So let's see. It multiplies the H, but again, it also multiplies the O. All right. So do we just multiply the 3 by the 2 and get a 6? No, it's not. This is wrong. Don't do this. Because if you look closely, the 2 only multiplies the O from the H, which is that 1. So I need to multiply this by a 2. Gives me a 2. So now 2 and 2 gives me a total of 4. I have now 4 H's right there. Okay. So now look, you got 4 O's, I mean not H's, O's on the right, 2 on the left. So again, the low side is the left side now. So again, I need to multiply this by a number to make them equal. All right. So again, how do you get that number? High side divided by the low side, which is 4 divided by 2. So 4 divided by 2 is 2, and this gives me a 4. And again, that 2 is now your new coefficient. All right, you check. Does it multiply anything else? No. All right. Therefore, that 2 is done. Check if everything is balanced. If you look closely, everything's the same, so we're done. So the coefficients here will be a 1. Oxygen, O2 will have a 2. CO2 will be 1. And H2O will be 2. So the coefficients to balance this set will be 1, 2, 1, 2. All right. And that's how you do this thing right here. All right, let's do the question number 19. What type of reaction occurs when potassium iodide reacts with lead nitrate? All right. Okay. For this one right here, you may want to use our flowchart, this flowchart right here. Okay. So just to make sure, let's just use the flowchart. Remember, guys, in the flowchart, the boxes are the types of reaction. Okay. The boxes right here are your types of reaction. Okay. Let me get that thing out of the way first. The boxes right here, you guys, are the types of reaction. Okay. And oh, there's still one more block in the way. There you go. All right, let's do number 19. What type of reaction occurs when potassium iodide reacts with lead 2 nitrate? All right, so for this one, you may want to use our flow chart. All right, so let's look at our flow chart right here. So let's do this step by step. So again, always divide the equation first in half. Okay, so ask yourself, first question, do you only see one product or one reactant? Well, let's see. I got two reactants, two products. Therefore, the answer for that is no. Let's go down. All right. Do you see O2 as a reactant and H2O and CO2 as products? Okay, I don't see any of those, so the answer is no. Okay. Do you see two compounds on each side? So let's see. Is this a compound? Again, guys, when you talk about a compound, right, that means you have more than two or more elements combined together. So we're looking at capital letters. All right, so let's look at capital letters. How many capital letters do you see? I see one, I see two, therefore this is a compound. All right. How about the next one? I see three capital letters there. One, two, three, therefore a compound. Right. On the product side, let's do the same thing. One, two, three, that's a compound right there. And here, how many capital letters do you see? Two, therefore that's a compound right here. So the answer for this one is a yes. Okay. So this is a yes. So therefore we hit this box and that's the answer. So this one is a double replacement. Okay. This one is a double replacement. All right. But remember, guys, if it's double replacement, it can have one of two special types. So let's see. So let's see the bubble there. It says there, do you see two aqueous reactants? All right. You can clearly see it. Aqueous means it's in solution, it's dissolved in water, and it's right there. AQ means aqueous. All right. So both of them are AQ. All right. And do you see a solid product? S is the solid right there, and that's your precipitate. Don't forget. So the answer here is yes. Therefore, this one is a precipitation reaction. So look at your choices, and the answer there is B. All right. Now, okay, let's do some scenarios. So, for example, guys, what if there's no S? What if they're all AQs? Is this a precipitation reaction? No, it's not. Okay, since you don't form the solid, this is not a precipitation reaction. All right. Okay. What if the solid was not on the product side, but it was on the reactant side? So let's say this was the solid. Okay. I got two AQs, but it's on the product side. And then I have one solid, but it's on the reactant side. So is this still precipitation? The answer is still no. Remember, the AQs must be on the reactant side. The S must be on the product side. All right. So don't forget that. Okay. So this one is a precipitation reaction because we followed our flow chart. All right. Okay. Let's do number 20. Okay. Question number 20. What products are formed when HBr and ROH react in an acid base reaction? All right. So, first of all, HBr. HBr. If you look closely, guys, at HBr, HBr starts with the H. So, this one right here is your acid. Okay. All right. Let's talk about RBOH. All right. If you look at RBOH, you can clearly see that the RBOH ends in OH, and therefore that is your base. All right. And remember, guys, you can switch these two. The base can go first before the acid, right? The base can come first, okay, instead of the acid. All right, what happens here is the H and the OH join together to form your H2O. Okay, and that is your water. So the first thing they form is water. Okay, now what happens to the leftovers? All right, the leftovers, they join together. Okay, so these two right here, they join together. You write them down in order. RB is in the front, so RB goes first. Okay, BR is at the tail, so you write that last. Okay, so what do you call that? So this is your salt. Okay, so in acid base or neutralization reactions, remember this is called neutralization reaction. Okay, you always form water and salt. Don't forget. And this is again a special type. This is a double replacement reaction. All right. If you look closely, this is a double replacement reaction. So these are the products that you form. Okay. So the answer here is what? The answer here is water and your salt. All right. That's question number 20. Let's look at question number 21. What are the products of the reaction shown below? All right. So again, let's see. HBr starts with the H, therefore this is your acid. Okay. KOH ends in the OH, therefore this is your base. Again, the H and the OH join together to form your water. So the first thing that you form is water. And this is your water right here. Plus, okay, what happens to the leftovers? Again, the leftovers, they join together. Okay, that forms your salts. So write it in order. K is at the front, so K goes in the front. BR is at the tail, so that goes at the end. So that's your salt right there. So these are the products of the reactions shown here. And this is an acid-base reaction or a neutralization reaction. And again, guys, this is double replacement. Okay, again, this is double replacement right there. Okay, all right. Let's look at question number 22. Which of the following reaction is an oxidation reduction reaction? All right, guys, when you read oxidation reduction reaction, that's your redox reaction. So we're looking for something that is redox. So again, we're looking at one that is redox. All right. So how do we know again, guys, if it's redox? If you go to our flow chart, it has to be the green box, one of these green boxes right here. Okay. And you can use your green boxes, I mean your flow chart now to determine the type. Okay, so let's see. So look at A. If you look closely at A, all right, and if you follow the flow chart, you're going to see that this is a double replacement reaction. Okay, hopefully you did it and you found out this is a double replacement. What kind of double replacement? It's a special type. This is called a precipitation. Okay, all right. Look at the second one. If you look at the second one, if you did the second one correctly, you would find out that the second one is a decomposition reaction because there's only one reactant. So this one is the decomposition. All right. Okay, do the next one. Use the flow chart. Right. If you do it correctly and you follow the flow chart correctly, the next one is a combustion reaction. Okay. Because again, you have O2 before the arrow, and then you have CO2 and H2O after the arrow. Okay. All right. Let's do the last one. If you look at the last one, guys, And if you do this correctly, you would know that this is a double replacement reaction as well. Okay. All right. So let's look at our flow chart one more time. So if you go back to our flow chart, you can clearly see that the only ones that are redox are synthesis, okay, decomposition, combustion, and single replacement. Double replacement, precipitation, and acid-base reactions are not redox reactions. So, which one is a redox reaction? Okay, which one is a redox? If you look closely, guys, the only the is a redox. So the first one is not a redox. So X. Okay, decomposition is a redox. So that's a check. Okay. Combustion is a redox. That's a check again. And finally, the last one, double replacement, is not a redox. Check. I mean, check. X. So there are two answers here. It's B and C. Okay, there are two answers to this question right here. B and C. Decomposition and combustion are both redox reaction. And let's check. Decomposition is green, so redox, combustion, redox. So again, decomposition and combustion is redox reaction right there. All right. Good. So the answer here is letter B and letter C. Very good.